Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about solving systems of three equations with substitution.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, 3x minus 3y equals a negative 6, z equals a negative 3x minus 3y plus 9, and negative 4x plus 5y plus z equals 8. And we need to solve the system by substitution. First thing is, I'm going to look at this first equation here. 3x minus 3y equals a negative 6. I'm going to try to get x by itself. So I can pull out a 3 from both parts here, and I'm left with an x minus y equals a negative 6. By dividing 3 to both sides, I now have x minus y by itself equals negative 6 divided by 3, which is a negative 2. From there, I added y to both sides, and x is now by itself, and it's equal to a negative 2 plus y. Okay, so we have x in terms of y. Let's try to get z in terms of y. So our second equation right here, let's rewrite it down here, is, well, z equals a negative 3, and instead of x, I'm going to use the x values that we found here, the negative 2 plus y. Then we have a minus 3y plus 9, and now look at this. We have z in terms of just y. So let's simplify where we can. Z equals, distribute the minus 3 to both parts here, and we have a positive 6 and then a minus 3y. This minus 3y comes down, and we have plus a 9. Well, now let's combine our like terms. Z here, 6 and 9 become 15. And negative 3y minus 3y is a minus 6y. So now we have z in terms of y, and we have x in terms of y. Where can we go from here? Well, we want to have only really y by itself. So if we look here in the last equation, we can see we have z, we have x, y, and z, and we can plug in these values for z and for x in there, and we have an equation with only y. So let me do that over here. I'm going to rewrite that equation, the last one. So right here. Negative 4, and instead of x, I'm going to put this minus 2y, or minus 2 plus y, excuse me. Then we have plus a 5y plus z, our z value, which we found to be 15 minus 6y. And that's equal to 8. From there, we want to simplify. Distribute the negative 4 to both parts, and negative 4 times negative 2 is a positive 8, and negative 4 times y is a minus 4y. The 5y comes down, and then we have the 15 and the minus 6y here, equals 8. Alright, now let's combine our like terms from each side. Negative 4y plus 5y minus 6y comes out to be a negative 5y. 8 plus 15 is a 23, and that's equal to a positive 8. We subtract the 23 to both sides, and we have negative 5y equals 8 minus 23, which is a negative 15. Divide both sides by negative 5, and y equals a positive 3. We now have our y value. Well, now the rest of the work's pretty easy. We plug y in right here, and we get our x. So we have x equals negative 2 plus the y value we found, which was 3. And, well, negative 2 plus 3 is equal to a positive 1. So we got our x value here. Let's go find our z value. And z is equal to 15 minus 6y. So let's put that 3 in for this y here. And we simplify. Okay. Z equals 15 minus 6 times 3 is 18, and I'll put z here is equal to 15 minus 18, which is a negative 3. So we can write this as a coordinate point to be 1 for the x, 3y, and negative 3 for the z, and that is our final answer. X equals 1, y equals 3, and z equals negative 3. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.